In general, single-phase motors use a capacitor to split the phase. Some motors, like the ones found in fans, have the capacitor permanently connected to the supply. In some motors, the capacitor is used only for the starting period, and then, while running, it is disconnected from the supply by the use of a centrifugal switch mechanism. In this exercise, we are going to learn to rewind a single-phase, split-phase type motor with concentric coil winding. In the process of rewinding these type of motors, we are going to record nameplate details, dismantle the motor, collect winding data, develop a connection diagram, remove the stator coils, insulate the stator slots, prepare former for rewinding, wind the coils, insert the coil into the slots, connect the coil ends and form the overhangs, assemble the motor, test the winding, inspect and test run the motor, varnish the winding, and then finally test the motor on load. The tools required for the purpose are an electrician toolkit, a pair of scissors, mallet of 8 cm dia, soldering iron, a working tray, scale with weights up to 2 kgs, cold chisel, 500 volt mega and a multimeter. First, remove the pulley. Let's look at the nameplate details that we need to make note of. The manufacturer's name, the trade name and the serial number, the output capacity, voltage and current, speed, duty cycle, insulation, frame and the starting capacitor. Loosen the screw bolts on both end shield covers and also remove the rotor from the stator. Remove the fan cover and then remove the cooling fan blade assembly. Inspect the rotor for any visual defects. If any of the rotor bars is open, correct it by brazing. Inspect the bearing for its condition. If it's worn out, replace it with a new one. Mark and remove the connection leads from the terminal box. Enter the details in the table. Collect all possible data before removing the coil and record it in the standard table provided. Draw the group connection diagram and also prepare the developed diagram in a separate sheet of paper and maintain it for your reference at the time of assembly. A sample group connection diagram and a developed connection diagram are shown here for your guidance. Measure the overhang at both sides of the winding. Record it in the table and prepare a template. Collect all possible data like number of slots, coil pitch, and record it in the table. Leave one set of coil each in the starting as well as the main winding and cut the remaining coils with the help of a cold chisel at the non-connection end. Strip the old winding from the stator slot. Finally, remove the left-out coils in their original shape. Measure the size of the wire and the coils and record them on the table. Next, we are going to see the procedure of rewinding the motor. Clean the slots properly. Use an insulation paper of the same grade and thickness as in the original and make it of the same shape and size as in the original insulation. Insulate the slot with that insulation paper. Make a former according to the original set of coils. With the correct size of winding wire as in the original, wind the coil in the former, taking care to maintain the same number of turns. Make the required number of main and starting winding coils. The running winding should be placed at the bottom of the slot and the starting winding should be placed at the top as per data collected. Insert the newly wound main winding coils into the stator slots, placing the winding in the same position as in the original. After placing all the main winding coils, shape the coils on both sides. Check the individual groups of the main winding for continuity and insulation resistance using the multimeter and megger. If they are found correct, then place the starting winding in the designated slots as per the group connection and developed diagram made at the time of dismantling. Wherever the slot contains two coil sides, take care to place a separator insulation paper after inserting the bottom coil side. Provide a phase separator between the running and starting winding coils in the overhang. Shape both sides of the overhang as in the original with the help of a nylon hammer or mallet. Be careful not to damage the wires or insulation. Next, insert PVC sleeves in the winding ends and connect all the coil ends and lead cables according to the connection diagram prepared earlier. Confirm that the connections have been made as per the group connection and developed diagram. Solder the end connections and put the sleeves in position. Set the overhang sides so as to have a uniform thickness and bind it with a thread or tape similar to the original. Make sure that the overhang does not touch the body or end cover. Now that the rewinding process is over, we move to the final phase of testing it. First, check the winding for short or open circuit using a multimeter. Check the condition of the capacitor, replace them with new ones if you find them defective. Connect the lead connections, capacitor according to the connection diagram and terminal box. Assemble the motor and give it a trial run for 15 minutes. Observe the direction of rotation. If found incorrect, change the connections. Then, dismantle the motor, preheat the stator and impregnate the winding with varnish. Reassemble the motor and test it on load for a period of 8 hours. In this exercise, we saw the procedure of rewinding a single-phase split-phase type motor with concentric coil winding. In some motors of this type, there will be two capacitors, one for starting and the other for running. Depending on the power, function and the design of the motor, the capacitor value will be different in each case. So, always observe this every time you come across the split-phase motor.